130 cylinders are stacked in rows in such a way that the number in a row is one less than the number in the row below. The bottom row contains 16 cylinders. How many rows are there, and how many cylinders are there in the top row? So I've drawn a word picture here and summarized the question. There's two things we need to work out. How many rows do we need for 130 cylinders in total? And how many cylinders in the top row? So, and it carries on going, doesn't it, up to there, ... So let's have a look at this then. We can do it ad hoc. It doesn't tell us to use any particular method, so with small numbers we can actually do problems like this ad hoc. And sometimes it's a more direct and simpler and straightforward method. So I'd like to show you that method first. So here we've got 16 plus 15 plus 14 plus ... equals 130. So how many of these numbers do we need to add together to get to 130? Okay, let's just tap it in the calculator then. So it's 16 plus 15. We'll tap a few of them in first, and then we'll tot them up as we go. So 12, 11, 10, 9, that should be okay. We get 100 so far, so let's add a few more. 8, then 7, then 6. So we get 121 so far, going down to the sixth, the row with the 6 cylinders in. So we need to add a 5 and a 4, don't we, to get to 130, plus 5 plus 4. So we went down to 4, didn't we, to get 130. So we just tapped it out and we got the answer. So let's just write them down, each one of them individually. It doesn't take a moment to do. And that total equals 130. So top row has 4 cylinders, and there are how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 rows. So that's one way to do it. It's quite a quick and direct method. Because the numbers are small, it's advantageous in some ways to do it that way. Let's now turn our attention to solve it in an alternative method using solution by quadratic equations. So we'll do the algebraic method now then. So how many rows needed for there to be 130? So the sum, so A, the first term, is 16, agreed, in the sequence. It's a arithmetic progression, so the common difference, you're taking one away each time for each subsequent term from the previous, aren't you? Okay, we don't know how many rows we need. The number of rows is n, isn't it? But we do know the formula for Sn. It's n over 2, 2a plus n minus 1d. So we can put the values in, and we know that sum will add up to 130, and we'll have a quadratic equation in n. So let's do that then. So n over 2, 2a is 2 16ths is 32, plus n minus 1 lots of d. And d we put in is minus 1, put a bracket around it, because there's a minus tagged with it. Close that bracket, equals 130. So what have we got then? We've got n over 2. Here this is a 1 it meant to be in here. So I just make sure I've written 1. So I'm going to expand this bracket. See, you draw 2 lines when you expand a bracket, that one and that one. So we've got 32 there. Minus times minus is a plus 1, so it's 33. And this, when you expand the minus to the end, you get minus n. So that equals 130 then. Multiply through by 2, all the way through the equation. The other way to look at it is move the 2 from divide on one side to times on the other. And when I've done that, that 2 comes up there. So it's 2 130s is 260. Now the 2's moved up there, I'm going to expand the bracket at the same time. So I'm doing two things in one fell swoop. Minus n squared, when we expand it, I'll write that one first, plus the 33n. So this is what you get when you expand the bracket then. So let's move everything over to the right hand side and flip the signs, move that over, n squared. Move this over, minus 33n, and there with the 160, aren't they? There's nothing left on the other side. And I've written it down from right to left. Now this is a quadratic in n, which hopefully will factorize because there's a particular number of n needed, isn't there, for this sum to add to 130. So we should be able to find the value of n by factorization. So look at 260. We're doing factorization next week. 26 times 10, or it's 13 times 20, isn't it, if you think about it? Half that one, double that one. 13 20s are 260. These two numbers add up to 33. So that's good news. So here we've got, I flipped the sign of those two, right? And that then becomes a minus, but when you bring it over it becomes a plus, so that's fine. I've got that correct now. So here it's going to be minus 13. I did 2 steps in one there. Minus 20. So let's try these two, see if this works. When you have quadratic brackets like this, you draw 4 lines. First line, when you expand the bracket, is n squared. The second line, minus 20n minus 13n. They combine to make minus 33 lots of n. And then these two, minus times minus is a plus. 13 20s are 260, as we said. So n equals 20. That's not a possible solution, is it? Because we can't possibly have 20 rows because we only start with 16 cylinders. So that's not a solution. So the only solution that comes from this is that n is 13. So we've got 13 number of terms. So that would, number of terms is the number of rows, isn't it? Okay, so the number of terms is the number of rows, which is 13 because we started from the first term being the first row. So top row equals, now when you go up equals the 13th term, doesn't it? Because there's 13 rows and each row corresponds to the term, its corresponding term, so 13th term, which is a plus 12d, isn't it, according to the rules for arithmetic progressions. A is 16, d is minus 1. So 16 minus 12, when you multiply this, is 4. So top row has 4 cylinders, as we said, by the ad hoc method. So the ad hoc method is a lot easier with these small numbers, but had the problem been much larger numbers, then we would have had to resort to the algebraic roots.